Hello, everyone. Thank you for coming to the session. I'm Ruela Mendonça. I'm a program manager at Microsoft, and I'm here to talk to you today about optimizing Windows apps across screens, in particular with the context of Continuum for phone. So a lot of you over here probably know what Continuum for phone is, but I'd like to give you a quick refresher anyway. So many of you probably have more than one device that you carry with you. You probably have a phone, a PC, maybe a tablet. For me, I just carry my phone around with me. And when I use my phone, when I'm on the go, I use it just like a phone. And when I want to sit down and actually be really productive, I plug it into a dock, a monitor, keyboard, and I get the full productivity of a PC that I want and like in high quality. Continuum for phone pretty much allows your phone to be like a PC. So there are a number of ways in which you could connect to Continuum. The first way is what I'm doing right now. I'm actually projecting this PowerPoint presentation right from my phone. I'm using a wired dock, like the Microsoft Display Dock. The Microsoft Display Dock has 3 USB ports in the back of it that allow you to connect to any peripherals you care about. It also has an HDMI out and a DVI out port to connect to the monitor that you want. And there is the USB-C power input to actually power the dock and your phone. On the front, there's a USB-C connection that goes into your phone and allows the projection to actually pipe through. So since I'm projecting from my phone, I'm going to quickly show you a demo of Continuum and some of the cool features that it's got. So right here, you can see that I've got a full screen UI showing up over here with my taskbar going around the bottom. I've got my action center showing up on the bottom right. And I've got apps that are running showing up in my taskbar. I can also see my start menu. And it shows up just like I would expect on the left of my screen. The first app that I would like to show you, and I'm going to go through a few apps, some first party, some third party. The first one is the Windows Store app. So you can see when the Windows Store app shows up in Continuum, I see the experience that I expect on my desktop, for example, where I've got tabs on the top, I've got a search bar on the side. A new thing that just got added to the Windows Store app is if I go into the collections view, I now have a Continuum for phone collection. Note that this collection is not an exhaustive list of all the apps that actually support Continuum. That list is much bigger than this, but these are a select few that we know work really well with Continuum. So you should check out this collection and try out Continuum with some of these apps. One thing that's really exciting about Continuum, I told you that it's all about productivity. So we do have the Office suite that actually runs in Continuum. You've got Word, PowerPoint, Excel, and OneNote all running over here. I'm going to quickly go into Excel to show you how it looks like over here. So as you can see, this is a view I expect to see on a larger screen. I have been working on this Excel sheet to actually track my travel expenses. And right here, I'm using my keyboard that's actually connected. And I can quickly enter my travel expenses right from here and let Excel actually work its magic. I have a ribbon on the top. I have all the controls that I want and need, and they're actually taking advantage of the screen space on this connected screen. Another Office app that's one of my favorites is OneNote. I actually use it to track a lot of lists and my reminders, etc. So in here, I've got a running list, and I can continue to edit it once I learn how to type. And add stuff with my keyboard and mouse. So I'm using OneNote. Again, I've got my ribbon and the controls that I really like and I'm used to showing up over here. This is the same UWP that I would also use on the desktop. But having the Office apps is great. One thing that a lot of people actually want and need to be productive is having a full-fledged browser. So when I open Edge in Continuum, you can see over here that I have my browser show up like I would expect on a larger screen. I can open multiple tabs over here, and I've got views such as the website views, which show up in a desktop view. So I can see more content and actually be more productive with it. As I'm doing this, I would like to show you, hold on. I actually want to share this page now with a friend of mine. So I can actually share and launch the messaging app right on my big screen while I'm browsing. And because this whole experience is powered by my phone, I can send a message directly from here. And my friend's probably received the message right now. I told him not to respond. Right here, if I switch over to my phone screen, you can see I've got a browser experience running in Continuum. When I switch over to my phone screen over here, I can open my mail app, for example, and continue to browse through my mail app and look at my mail without actually needing to change the context that I have on my connected screen. Another thing that I wanted to show you was the controller. So in case you don't have a keyboard or a mouse with you, you can always use the controller to control the second screen. This is especially useful when I have a Continuum session running on a television, for example, and I want to control what's going on that screen. So if I switch back to my Continuum screen, I'm going to use the controller now to actually control it. You can see that with this controller, I have my PTP gestures, which I'm used to with a regular touchpad. And I can also use a keyboard right over here to actually enter content into my application. The reason this is important to keep in mind is as I go through how you develop apps for Continuum, you need to know that you need to optimize apps not only for a physical mouse and keyboard, but a user could also be using something like a controller or a keyboard on their phone to control the other screen. So those were a bunch of first-party apps that work really well in Continuum. There are also a lot of UWP third-party apps that work really great. Today, I mostly want to go through one particular app which has recently come into the store, which is the VMware Horizon client. So with the VMware Horizon client, what I can do is I can set up my server over here and access all my virtual machines. I just showed you how I could actually project Continuum through a wired dock. I could also use a wireless dongle. This simply means that I can connect wirelessly to a display and get the keyboard and mouse input. There are three main wireless hardware options that we recommend. These ones, with the latest firmware update, Microsoft has actually verified that it gives you really good mouse performance and connection reliability. The first one is the ActionTech ScreenBeam Pro. The second one is the ActionTech ScreenBeam Mini, and the Microsoft Wireless Display Adapter. With the anniversary update, we also made it possible for you to project to any Miracast-capable PC. So if you have a PC that supports Miracast already, you can take your phone and project a Continuum session to that PC and use the keyboard, mouse, and peripherals attached to it. And there's also the clamshell form factor. This is a form factor that looks like a laptop, but is powered completely by the phone. So you can have a keyboard, mouse, battery, or any other peripherals in it. This is especially useful for when you're on the go and you don't actually want to carry a dock or find a monitor somewhere. You can have a full PC-like experience with just your phone. And I'd like to take some time to talk about the HP Elite X3. This is the new phone that HP came out with, and it comes with a bunch of really cool accessories. So there is the USB-C to VGA adapter that it comes with, the USB-C to HDMI adapter, and it also has two types of docks. The first one is the HP Desk Dock, which has a bunch of ports in it and allows you to project a Continuum session. And the other one is a clamshell type form factor, which is the HP Lap Dock. This is not the complete set of HP's accessories. They actually have a booth here at Ignite, number 421, where they've got some of these devices, so you should go and check it out and play with it. So for the next part of the session, I'm going to quickly switch my screen over. OK. So this is going to be the major crux of the session, which is developing for Continuum. When you're actually looking to develop an app that scales well in Continuum, we mostly ask you to actually investigate universal Windows apps that are adaptive. So in general, developing for Continuum is all about building Windows adaptive apps. So to support Continuum, you need to ensure that your app dynamically scales to the display that it is on. So if you build a Windows app that works on Windows Mobile, your app should work in Continuum. However, if you build that app for desktop and Xbox, it's not supported in Continuum directly. So there are a handful of considerations for developers as they think about Continuum. Some of them are integral to the success of your app on Continuum, while others are completely optional. The ones that are integral are make sure you're building adaptive apps that can adapt to any screen, and make sure that you're targeting the right device family. And I'll go through each of these in more detail. The optional ones are add scaling assets in order to make your app look pixel perfect, and take advantage of the fact that Continuum is about using two screens at the same time, where you've got the primary screen, which is your phone, and the secondary screen. So build multi-screen experiences when you can and when they're useful. So when I talk about building adaptive apps, what am I really referring to? When a user is interacting with our feature, we generally expect that when they're on the phone, they're going to see phone-optimized UI, and when they're on the larger screen, they're going to see large screen-optimized UI, which is probably going to be interacted with a physical keyboard and mouse. So if a user is interacting with a Windows app that targets the universal app device family, which means that it actually targets the desktop as well, I would expect to see my desktop UI on the big screen that's connected. However, if it targets only the mobile device family, you would still see it work in Continuum, only it will have the basic reflow that is offered by that. So, but you don't have to do anything special in this particular case. If you use standard adaptive techniques and you actually adapt them to the primary display, which is your phone, and your secondary display, which most commonly is either a small or large monitor or a television, your app should be fine. But to make your app truly adaptive, you can do this by using responsive design. I'm going to go through three main points over here. The first one is adjust your content density to screen size. When I'm on my phone over here, it's a much smaller screen size, and I obviously do not want to overwhelm the user. So I adjust my content density to actually fit that screen and be optimal for use. When I'm connected to a larger screen, if I just use the same phone design, it may look really sparse because I've got so much more space over there. So you should optimize your content density to the screen size and the display that you are on. Take advantage of device capabilities. My connected monitor may not have a webcam, it may not have a GPS with it, but my phone does, right? And since my Continuum experience is powered completely by my phone, you should take advantage of the device capabilities you have over there to make sure that you're actually using some of these when you're building your app. And the third one is optimize for input. With my phone, I'm probably going to be in a touch-first environment where I'm actually touching my phone and scrolling with my thumb a lot of the time. While when I'm on a larger screen, I'm probably using my keyboard and mouse or the controller app that I showed before. So make sure that your app is actually optimizing for input. When you're optimizing your app for specific screen widths and actually adjusting it to that, that's what we call responsive design. So I'm going to go through a few responsive design techniques, and I'm going to do this by taking a deep dive into an app. This is a simple purchase app where you can actually go in, look at more information about different things, and purchase it. So I've got this app currently running on my phone and my desktop, and I'll go through each of those. The first responsive design technique is around resizing your app. So when you get a Windows size change, your app should resize to any screen. You can do this by adjusting the frame size or actually stretching the elements that are in your app. In this particular example, you can see that the content frame gets adjusted to include more when it's on a larger screen and adjusted to include less when it's on a smaller screen. So if you look at this in context of the app, you can see that the cover photo on the top actually scales and stretches to adapt to the larger screen. I'm going to So right here, I've got an app that's running on my desktop. And you can see that I've got a cover photo that actually scales to that screen. So right here, you can see that my photograph has stretched to take up the entire screen. If I actually look at my phone screen right now, I've got the exact same app running. And the app over here actually has my photograph taking up the screen width of the display. So if I had to look at how this would actually work in code, okay. If I had to show you what this looks like in code, I simply use the stretch property. I use the stretch property, and I tell the stretch property to actually uniformly stretch across the screen. The second responsive design technique is around reflowing your app. So this basically means that you change the flow of UI elements on the device and the orientation, based on the device and the orientation, so that you actually see the right content on each screen. So if I'm on a smaller screen, I'd probably want to see a single column of content and a smaller content frame. When I'm on a larger screen, in this example, I can actually reflow to have multiple columns of content. In the sample that I showed you, this is represented by the column of photographs that I have over here. On the smaller screen, my photographs are all aligned in a single column. On a larger screen, they actually take a grid-like view to take advantage of the screen. So looking at the app running on the desktop, you can see over here that I've got a grid-like view where I've got multiple columns of content. And as I resize my app and make it smaller, you can see that it automatically realigns and reduces the number of columns on there. Similarly, on my phone, over here, you can see that all of the photographs are in a single column, and they're actually aligning to my phone screen size. So if I was to look at how we would code something like this, I simply do it by using the variable sized wrap grid control. So with the variable sized wrap grid control, I can actually just specify the content, in this case, the images that I want to show, and the variable sized wrap grid control takes care of aligning the content accordingly. So here, I've specified that the orientation is horizontal. It could be vertical. Horizontal simply means that my photographs would actually appear in a horizontal fashion, row first and then columns. The next responsive technique I want to talk about is the replace technique. This allows you to switch the user interface for a specific device size class. In this example, you can see that there's a nav pane that's touch-friendly and bigger when I'm actually on a smaller screen. However, when I move over to a larger screen, tabs may make more sense in that case, which is why you see tabs. Similarly, in the example that we have over here, you can see that to navigate between the panes, I have a hamburger menu with the different page options. While when I'm on a larger screen, I simply see tabs on the top, and you can switch between the screens through there. Looking at the actual apps over here, on my PC, you can see that I've got the tabs on the top, and I can navigate between my different pages using the tabs. While on my phone screen, I can actually pull out the hamburger menu on the top, which shows me a list of options, and I can quickly switch pages by using the options that show up in the hamburger menu. To look at the code behind this, I have actually created two separate layouts. One is a touch layout, and one is a mouse layout. So if I look at the touch layout, I can go in here, and in order to create this separate view, I use the split view control. With the split view control, I'm creating a new view that's triggered by the hamburger button, and this view shows up on top of the existing page. In this particular view, I then specify the cover photos and the album names that I want and allow them to show over here. Once I have this view created, I then use the split view content to actually navigate to the right page. If I move over to the mouse layout, in order to get the tabs that show up on the top, I use a simple pivot control. And when I use this pivot control, I just specify the links and the names of the pages that I want, and it allows me to actually see the tabs on the top. And in a little bit, I'll show you some of the techniques that I've used in order to know when to switch between these two controls. So moving back. The next responsive technique that's really important is around repositioning. So this simply means that you can alter the location and position of different UI elements in your app based on screen size or any other triggers that you're looking at. So over here, you can see that when I'm on a smaller screen, I have a more scrolling kind of UI because I've got only a single column available to me. However, when I move into a larger screen or maybe even a landscape orientation, I have more space, so I can see 2 frames at the same time, and I can actually show them side by side. I'm going to demonstrate this particular technique by actually using the text block over here. In the case of the phone, the text block always appears on top of the photograph because that's the space that I have available. However, when I move to the larger screen, I'd like to see the text block while I'm looking at a bunch of photographs at the same time. So I move it over to the right of the screen. So if I look at the app over here on my PC, you can see that I've got my text block to the right. But as I keep reducing the size of the app, it actually moves my text block to the top, on top of the photographs. This is because these responsive techniques don't only benefit when you're actually using Continuum. It also benefits when you're resizing an app on the same screen. So if I was to show you the app now running on my phone, you can see that the text block always remains on the top, and I can actually scroll the photographs, and the text block continues to remain on the top. So in order to implement this, I'm going to go back to the sample accessories page. And I use a visual state manager to actually manage these visual states. So I've got 2 visual states that I need to manage. And I use different adaptive triggers to figure out when I switch between these states. So when I talk about the visual state manager, the triggers I'm going to use today are around effective pixels. So for the first visual state, my trigger is that the min window width is equal to 720 effective pixels. This simply means if I've got any display which is 720 pixels or greater, I will automatically switch to this particular visual state. So I then use the relative panel class, and by using the relative panel class, I specify that I always want the text block to appear to the right of the photographs. So the relative panel class pretty much allows you to align an element relative to another element on your screen. For the second visual state, I use the adaptive trigger where the minimum window width is equal to 0. This means for any display where the screen width is between 0 and 720 effective pixels, I switch over to having the text block be above the photographs, and it will always remain above the photographs because I'm using the relative panel class. One thing to keep in mind is when I mentioned screen width, if you're running on the same device, your screen width could vary. So when I'm talking about screen width, I actually mean the amount of screen space that's available to your app at that particular point of time. The last responsive technique is around re-architecting the navigation and layout of your application. This just means that you can collapse or fork the architecture of your app based on the device class or the orientation that you are in. In this example over here, you can see that I've got a list pane and I've got a preview pane. Over here, when I'm on a smaller screen, I see the list pane that I have to click on individual items to actually move into the preview. While when I'm on a larger screen, I can actually see the list and the preview pane side by side and actually move between the different pages. There are some extreme cases where when you're actually moving between device classes, you may want to completely tear down the UI of your app and rebuild it for the screen. But often just a few tweaks could actually help you re-architect your app in a good way. So in this example, I've already shown you this, but this is a form of re-architecture where when I'm on a smaller screen, I actually want to show a nav pane at that point, while when I'm on a larger screen, I want to navigate the app by using the tabs on the top. So I've already shown you this in the app, so I'm going to straight away move over to my code and the main page.xaml. So with Continuum in particular, there's a really useful API called the User Interaction Mode API, which we encourage you to use. This basically has two return values, touch and mouse. So what I'm doing over here is when touch is returned, I choose to actually use the touch layout.xaml and actually use the nav pane layout. When mouse is returned, I instead actually move to the mouse layout and I use the pivots on the top. So I'm going to show you this app running in Continuum. You've seen it running on the phone. So right here, if I'm going to quickly switch inputs. I'm back in my Continuum session, and now I'm going to launch this app in Continuum. You can see over here that I'm running in Continuum, and this is very similar to what I saw on the desktop because I'm using simple responsive techniques. I've got my image that actually stretches edge to edge. I've got my different tabs that allow me to move between different pages. I've got my text block to the right, and I've got all of my images over here reflowing to actually take advantage of the screen space. So the next thing that I want to talk about is breakpoints. So these breakpoints help you understand when your app should actually be optimized for the phone versus when it should be optimized for the large screen. With the Windows device family, there are too many screen sizes and too many form factors for you to be optimizing your UI for each one. So we actually recommend using breakpoints to actually help you design for different display sizes. So there are three main breakpoint examples over here. You can see that we've got 320 effective pixels for the phone, 720 effective pixels for the tablets and larger phones, and 1024 effective pixels for desktops and laptops. So if you design for these specific breakpoints, again, you need to keep in mind that you're designing for the amount of screen space available to your app. So because of how the scaling system works, you're also not looking at physical pixels over here. You're looking at effective pixels. So you can ignore the pixel density and the screen size and instead pay attention to the effective resolution that you have available. So when you're looking at the phone, you think of an effective screen size of less than 800 by 600. And on the connected display, an effective screen size of greater than equal to 800 by 600. This is general guidance, and you can actually use other triggers other than breakpoints, like you can use input methodologies or any other triggers that you think is appropriate. But note that if you actually use these breakpoints, it benefits you in a UWP no matter which screen you're running on. The next topic I want to talk about is targeting the right device family. So if you build a UWP that can run on a mobile device, your app will run on Continuum by default. And if you use the standard adaptive reflow techniques, it will actually reflow to the larger screen. But if you build a Windows app, as I mentioned, that does not run on mobile, and you've tagged it as only being desktop and Xbox, it will not be supported on Continuum. So talking about that, the best thing you can do is just target the universal device family. This means that your app will be available on the whole Windows device family, ranging from your phone to a connected screen, PC, Xbox, HoloLens. If you were doing this, we of course assume that you're following a bunch of responsive design techniques that I've already spoken about, and your app will dynamically reflow to any screen. At this point, you're already doing everything you need to do to be supported on Continuum. And this is fine, but a lot of developers actually come from mobile-only backgrounds, and they're more comfortable building mobile-only apps. So if that's the case, if you build your mobile-only app with fluid and responsive design, it should work on Continuum, and you'll get some basic reflow and adaptation for free. But you may not be completely happy with this, and that's why I went through the techniques that you should use to actually make your app look really great on Continuum. So if you use those techniques that I actually went through, and you do a little extra work, you can further optimize your app to work really well on large screens. Another thing to think about is if you already have a view that you've created for the desktop, you can just pull that in and apply that to the large screen view and just add the right triggers like input mode or breakpoints to actually render that view. That being said, if you find yourself doing a lot of work to actually adapt for Continuum, we suggest considering converting to a universal Windows app at that point. By building a universal Windows app, all of your work will actually benefit all of these different device families, and it will actually be able to render across all of them. Now, of course, you may actually build a mobile app, but may think it's not ready for Continuum because it doesn't reflow properly, or you may have some other issues with it. So it's pretty easy to actually block your app from Continuum. What you mostly need to do is you go into the manifest and you add a namespace to your package tag, and then you use the restrict to internal screen property. This property could be set to true. When it is set to true, this simply means that your app will only show on the phone screen, which is your primary screen. When you are on your larger screen, your connected screen, your app will show up grayed out, and if you tap on that grayed out app, it will tell you that it's not optimized for Continuum. We hope that you will optimize it for Continuum, so when you think your app is actually ready, you can just go and switch that true over to a false and submit an update for your app. The next section is what I called optional earlier. It's basically about adding scaling assets to your app. While optional, we recommend this, and I'll go through why it is recommended. So every device on the Windows platform has a particular scale associated with it. In this example over here, you can see that your phone probably has a higher scale than your connected monitor or your television. A phone generally ships with a scale factor of 150 or 250. Most monitors are just a scale 100. So you can see that there's no direct correlation between the screen size and the actual scale factor. So why are these scales important? These scales are used by the resource manager to actually decide which asset to show on which screen and at what time. So by default, when you actually install an app on your phone, it downloads the scale assets that are actually relevant to that app. So in this case, I've got a scale 300 phone. By default, it would download the scale 300 assets and not the whole list of assets that you have. The reason for this is obviously to conserve space on your phone. So when you connect to a monitor that has a scale 100, it wants to use the scale 100 assets. However, the first time, because only the scale 300 assets are downloaded, you may actually see the scale 300 assets on the larger monitor. Now, if you have provided more assets, you don't have to do anything extra, and it will automatically download those assets when you're connected to a second screen. We do optimize so that if someone has not connected to the same monitor in 30 days, we take out those assets again to conserve space. But by default, you shouldn't have to do anything more. Just provide the assets, and we'll make the right choices for you. If you do not provide a good set of assets, the biggest problem that you see in Continuum is downscaling. The reason I say this is a common scenario is phones generally have a higher scale than a monitor you're connecting to, which is generally a scale 100. Of course, you may have exceptions, so you've got a 4K monitor, and I'll go through that. But this is the most general case. So in this case, my phone has a scale of 400 over here. And when you're connected to a second monitor, because that's supposed to scale of 100, the assets need to be scaled down. And you can see it's not super clear in downscaling, but you can actually see that the assets are slightly blurry. if you do provide scale 100 assets, it would actually show you pixel perfect assets. Talking about 4K monitors, you could have a case where you have a really low resolution phone that's connecting to a 4K monitor. In that particular case, your phone has scale 100 assets. And when you connect to a 4K monitor, we actually have to stretch those out to make it work over there. In order to do that, you can see that the assets are quite blurry in this case. And this is why we say, to ensure that your users never actually see such blurry assets, consider including more assets in your app. So talking about including assets, how do you actually do this? To support this, there are two ways that I'll go through. The first one is adding a new resource to your assets folder. You just need to use the .scale-xxx notation. So over here, you can see the logo actually has 4 assets with the scale-100, scale-150, 200, and 300. And all of these are just included in the assets folder. The second is you actually create a scale-xxx folder and add the same titled images to each of them. And then once you have that, those bitmaps will automatically be selected. So if you use one of these two techniques, all you need to do to reference the correct thing is you actually leave out the scale-xxx, and the system automatically chooses the right asset for the right display. So you shouldn't have to do anything more than this. The last section that I want to go through is building multi-screen experiences. So this is especially useful when you are in Continuum, simply because you have the advantage of having 2 screens. You have the phone screen, which is your primary screen, and you have a connected screen. So your app can truly build rich experiences with this. So the first way to build multi-screen experiences is using the Cast API. So this is the built-in casting ability of the media element. And this allows you to actually show a casted media element on another screen while you still see your app on the primary screen. So you simply feed the desired media element, and Windows actually launches a view and shows you that media element. It's pretty simple to make use of this. The first step is to create a casting picker. This simply means that you're creating a UI in which a list of displays that are available actually shows up. You filter it to the media element you care about. In this particular case, it's videos. And then you add an event listener for the device selected event. When a user actually taps on the button that's supposed to render the list of devices, you show the selection UX at that time. And once you get the selected device that the user has selected, you can then use the casting device as desired. In the previous example that I showed you, it was used to actually cast the media over to the other screen. Now, the Cast API is great, but it is limited to media elements. So it's good if you actually want to build a video casting app or a music casting app. However, if you actually want to build rich multi-screen experiences and have full control over the view on both your primary screen and the connected screen, we recommend using the Projection Manager API. One thing to keep in mind when using the Projection Manager API is that you cannot assume that the screen that you're connecting to has a keyboard and mouse attached to it. So because of that, you should add all ways to control the connected screen into your primary view. And I'll show you a demo of a really good example of a Projection Manager API in a bit. So the first step to using the Projection Manager API is to check whether there's already an active connection to an external display. If there is no active connection to an external display, you would use the same methodology that I showed for the Cast API, where you create a device picker and you actually pick a device that's near you. In this case, there is an active connection. So you create a view for the second screen. This view is not visible yet. You're just creating it and keeping it ready. Once this view is created, you call start projecting async, and this actually shows the view on the second screen. And because I said that you actually need to be able to control the second screen from the first screen, you would also provide a mechanism to actually stop the projection and close down the view. So as an example over here, I'm going to switch back. So you can see the presentation over here. I'm running it in PowerPoint right from my phone. If I switch over to my phone screen, you'll see that PowerPoint actually makes a great use of the Projection Manager API. Over here, I can see the slide that's actually displayed. I can move back and forth between the different slides. I can see my notes, so I actually know what to talk about. And I can also see a list of all of my slides, so I can quickly switch between them when I need to. So I can go to my previous one or my next one right from here. On the top over there, PowerPoint also gives me the capability to close my slideshow, so to actually close down the view on the second screen, or even annotate on top of it. So that was most of what I wanted to talk about. There are a couple of calls to action over here. Make sure you're building adaptive universal Windows apps. This will benefit you not only in Continuum, it will benefit you when you want to resize your app on the same device. So there are a lot of benefits that come out of it. Remember that users can interact with your mobile Windows 10 apps on a larger screen with the keyboard and a mouse. So optimize for that. Consider adding scaling assets to make your app pixel perfect. And make sure to build innovative multi-screen experiences that work across your screens. I'm going to be in the Microsoft Showcase area right after. I'll actually stick around over here if you have any questions or you want to talk to me about anything. But there's a developer booth down in the expo where you can go and find folks who'd be able to answer more questions about UWPs and Continuum. Also, please evaluate the session. You can actually scan this code and evaluate it. We really value your feedback. The other thing that I did want to talk about was I do have two ScreenBeam 2 wireless adapters over here. So if any of you want to come and tell me what you really love about Continuum or your best use case for it, these are for you. Thank you.